We're going to take a really quick look at something called integration using tables. Now this is somewhat of an outdated method for integration now that we have computers and software to really help us with this. But this is the way we used to have to do really complicated integrals if we didn't already know how to do them. Now we actually already know how to do this. This is basically just integrating using a formula. And we do know some formulas that we use to integrate. Stuff like this. If I said du over a squared plus u squared is 1 over a arctan of u over a plus c. Now this is one of our formulas that we've used in the past to help us integrate things that have this form. So if we ran into an integral that looked like this, 1 over 9 plus x squared dx, we can see in this formula our a is equal to, well, 3 because that has to be a squared. Our u is equal to x, and of course du is dx. So this fits this form exactly, which means we can just plug it into the formula. Once we've decided it fits the form, we plug into this side and it's done. That would be 1 over a arctan of u over a plus c. Now, generally in any calculus book that you have, somewhere in one of the appendix, and in our appendix we have one, you have what are called integration tables, which is just a whole bunch of formulas like this. And if you can match the form, then you know what the integral is. So it's kind of like cheating a little bit. The problem is with this is it's not always easy to see that what you're dealing with has a specific form. Let's take a look at a much more complicated example. Let's say if I said, let's integrate sine squared x cosine x over 1 plus 3 sine x squared dx. All right, that looks absolutely awful. And if we were going to integrate this, we would go through all of our steps and all the things that we'd want to try. And we'd really have a difficult time doing this. But I took this integral and I flipped back to the appendix in the back of your book, and I tried to find one of the formulas that fit this. And actually what I found, they should be the same for all versions of the Larson textbook. I'm looking at number 7 in your book, and here's what it said. It says if you're integrating something that has the form of u squared over a plus bu squared du. So I said, well, you know what? Mine kind of looks like that, and I'm looking for the basic structure of this first. What do I have? I have two things down here, a number and a function, all of that squared, a number and a function, all that squared, something squared on the top, and maybe some derivative floating around. So notice if I take this, and I'm just going to rewrite it just a little bit, I'm going to write it as sine squared x all over 1, what did I say, 3 sine x squared, and then cosine x dx. Now to make it fit this form, let's see what we have. Well, our a would be that number, so a is equal to 1. B is the number in front of the function, so b is equal to 3. And our function, let's see if this works. Our function, I'm saying, would be u, would have to be sine x. So is u equal to sine x? Du would be, well, the derivative of this would be du is cosine x dx. So notice it fits this form exactly, right? A plus bu, our function's u. On the top we have u squared, and out here we have the derivative of u. So this actually fits this form. So now I look at my table and I say, well, the table says we know how to integrate this, and I'm cheating. I'm looking over there because there's no way I would remember this. Here's what the book says that this integrates into. It's 1 over b cubed. Let's see if I get this right. Bu minus a squared over a plus bu minus 2a natural log absolute value of a plus bu, of course, plus c. Now it's a horrible formula, but the good news is all we got to do now is plug in what we have. We know what a, d, and u are, which means we know what the integral of our function is. So let's start out. Our b is 3, so it's 1 over 3 cubed, so 27. Bu, well, b is 3, u sine, so that's 3 sine x, minus a squared. A is 1, so 1 squared is 1. 1 plus BU minus 2 times A. Again, our A is 1. So this is going to be 2 natural log absolute value of 1 plus 3 sine X plus C. Okay, so we took something that was absolutely awful to integrate, and we kind of cheated. We found a formula that had the exact same form, even though it didn't quite look like it, had the exact same form as our function, and then we just plugged the result in. Now, the hard part about this is if you looked at this originally, you wouldn't necessarily have thought that this fit that form, and that's the tricky part with these. The good news or bad news, the way you want to look at it, most of the time you're going to refer to a computer these days, you know, go to some nice piece of software like Wolfram Alpha and plug that in and see what it gives you. But the tables might give you a little bit more insight into maybe how it was done, because you can kind of see that this was probably broken apart into 3 different integrals along the way as they did it to come up with that result. All right, so integration by tables, you do have a small integration table in the back of your textbook, which you might find useful. But make sure you try at least a couple of problems like this just to kind of see how we used to have to do it back in the olden days.